welcome back to TRB revision series. In this series, we have already completed signals and system. So now we are discussing about analog electronics. Even in analog electronics also, we started from BJT. We have completed bipolar junction transistor. Then we were discussed about MOSFET. Then we were completed MOSFET. After that, we have started feedback circuits, feedback amplifiers. So in the last class, we have seen the basics of feedback amplifier circuits and some of the important features. Now, I told that at the end, I will give few more important things and how to identify the topology when a bipolar junction transistor will be given or operational amplifier will be directly given. What they will ask is, you will be requested to identify what type of topology it's given to us, whether it is voltage series topology or voltage shunt topology or current series topology or it is current shunt topology. Guys, can you hear me? Hope I am audible. So if there is any voice issues, please let me know. Okay. See, so we have discussed all these things. Next, now let me take some examples and I will show you how this topology is working here. So what we have to do is, we'll be taking, suppose let us consider an operational amplifier is given to us. It is very simple to identifying these natures. I am giving very small examples such that you can easily understand what I am trying to say. Let us assume there is one input supply voltage is given here. It is connected with the positive terminal and the negative terminal is connected with the ground. At the same time, there is one more feedback line. This is going from negative terminal to output terminal. This is going to be output line and we can take, this is going to be input voltage, this is input resistance Rn. What we have to do is, now the question is, you will be requested to identify the given topology. So it is very simple. First thing, identify the feedback line. It is clearly given, the feedback line location. Now from this feedback line, what we are going to do? Identify whether this feedback is directly connected with the output port or not. Your first target is, step number 1, identify the feedback line. It is very easy. Identify the feedback line. Once you find the feedback line, then the second step what you have to do is immediately check whether this feedback line is directly connected with your output port or not. If your feedback line is directly connected with the output port, then that is called voltage sampling. On the output side, we will be performing voltage sampling. If the feedback line does not connect with your output directly, then that is called current sampling. If it is directly connected, then that is called voltage sampling. If it is not directly connected, then that is called current sampling. If you are observing the given circuit, in our given circuit, we are observing that the voltage, the feedback line is directly connected with your output port. So we are considering it as the voltage sampling. Now your next target, focus on the input side. Whether the input line, once again say, whether the feedback line is directly connected with the input supply or not. If the feedback line is directly connected with your input supply, then what can we call? If it is not connected with your input supply, then what shall we call? That is the next difference that you must identify. Once you identify the difference, if you figure it out, how to find out the, how to check the input side, then you can easily give your answer. See, I will tell you. First thing, what we observed here, sir, on the output side, we observed here that is called voltage sampling. On the input side, if the feedback line is directly connected with your input supply, then that is called shunt mixing. If it is directly connected with your input, then that is called shunt mixing. Cross examine whether your feedback line is connected with your direct input or not. No, it is not connected because see the input line is here, whereas feedback line is connected with the non-inverting terminal. So if it is not connected, then that is called, if the feedback line is not directly connecting with the input, then that is called series shunting. Sorry, series mixing. It is simply called series mixing. That's it, sir. So what you have to do? You have to remember only one keyword. Always remember. If the feedback line directly connected with your output and input, remember like this. If it is directly connected with your output, then that is called voltage sampling. If it is directly connected with the input, then that is called shunt mixing. That's it. Only remember these two keywords. If it is not, if it is failed, if it is not directly connected with the output, then that is called the current sampling. If it is not directly connected with the input, then that is called series mixing. Rest of everything you can write by your own. Now if you observe the given circuit, the feedback line directly connected with your output, so that's why we are calling it as voltage sampling. Whereas it is not directly connected with the input, then that is called series mixing. So the correct answer for this given topology is voltage series topology. Output is voltage sampling, input is series mixing. Understand, sir? This is how we are identifying whether the given is a voltage series sampling, or voltage series or voltage shunt, whatever. So let us take one more example for a better understanding. Let us assume we have once again op amp. It is given that supply voltage is given. This is positive terminal. This is feedback resistor. This will be your input resistor. This is your supply voltage. Tell me, sir, what topology it is? Now, if you are observing this, first thing, cross-examine whether this feedback line directly connected with the output or not. If it is directly connected with the output line, then that is called voltage sampling. If you are observing, yes, the given circuit, voltage or feedback line is directly connected with the output, so that is called voltage sampling. Correct, now, sir? Now, cross-examine on the input side what's happening. On the input side, feedback line is directly connected with the input also. If it is directly connected with the input also, then that is called what? See, this is the input line. Feedback line is directly connected with the input. If it is directly connected with the input, then that is called shunt mixing. So now, just to club them together. So this is voltage sampling shunt mixing circuit. So voltage shunt topology. Understand, sir? So that is how we are identifying different types of topology where it is being asked in the examination. Hope you understand. Similarly, you can apply same. See, even if they are giving BJT, bipolar junction transistor, just a cross check. For an example, let us assume a bipolar junction transistor is given like this. Okay, and let us assume there is one input source that is connected on the base terminal. This is input resistor. Let us assume that is base resistor. This is emitter resistor. Everything is clearly given. And here this is collector circuit. They are measuring the output voltage at this point. Now, what they did here is, after doing all, they simply attached a feedback line between input and output point. A resistor, a common resistor which is connected here. Fine, sir. Now you can observe, yes, there is a feedback resistor that is connected between output line and input line directly. If you are requested to identify the feedback topology from the given circuit, what you have to do? Cross-examine whether the feedback line is directly connected with the output or not. If it is connected, then what will be your answer, sir? Output will be voltage sampling. And cross-check whether the feedback line is directly connecting with the input or not. If it is directly connected with your input, see there, yes, it is connected with the input. Then that is called what, sir? If it is directly connected with your input, then that is called shunt mixing. So the correct answer is voltage shunt mixing. All you have to do is the location of feedback. Where is the exact location? Whether it is directly connected to the feedback or not. If it is not, then no worries. See, in the same circuit, suppose if it is given, they have not considered the feedback here. Rather, there is a resistance, feedback resistor is given, that is connected here. Okay. Now what will be your answer, sir? First, cross check whether the feedback line is directly connected with our output or not. No, output line is here, whereas feedback line is connected somewhere else. If the feedback line and output line are not directly connecting each other, then that is called output sampling. On the output side, we will be performing current sampling. Whether the feedback line is connected with the input or not. If it is connected, then that is called what, sir? If it is connected, then that is shunt mixing. If it is not connected, then that is series mixing. In the given circuit, feedback is not directly connected with the output, so it is called the current sampling. But it is directly connected to the input, so it is called shunt mixing. So the correct answer is current shunt topology. Hope you understand, sir. This is how we are identifying feedback topology when a circuit will be given and you will be requested to calculate the value of feedback resistance. Okay. Now I will tell you the various types of circuits. You might know all these things, but let us recollect once. First thing is mixing means this will always be taken on the input side. Mixing word, we will have to use it on the input side. Sampling, we have to use it on the output side. The word sampling refer the output. So we will be taking some samples on the output side. Now how we are going to design the amplifier circuits? Now I will show you the various types of representations of the amplifier circuits. It's very simple. For an example, suppose let us assume I have a forward path gain. Okay, a line will be given like this. We are taking feedback now. Now while taking feedback, there are two types of feedback taking. First one, for example, if you are taking the sample through the feedback line like this, see that this is the output port. This is the output port. From the output port, if your feedback line will be taken like this, then that is called series sampling. This is called series sampling. That is, we are taking current as the sample from the series point. Suppose on the output side, if it is represented like this, it is given, this is the output, but you are taking the feedback like this. This is called shunt sampling. That is, on the output side, we are taking voltage as the sampling. The previous one is current sampling, and the present one is, this is current sampling, this is voltage sampling. Similarly, on the input side, same way, if it is in series, this is called a series configuration, and this representation is called parallel configuration. This is parallel. On the input side, if it is represented in series, it means we are mixing. In series circuit, we can mix voltage only. So in series circuit, we are mixing voltage. If you are taking parallel configuration on the input side, it means we are mixing current. This is mixing circuit only, undoubtedly, but that is shunt mixing, parallel mixing. In shunt, we can mix the current. This is the difference between input and output side. On the output side, we are calling it as sampling. On the input side, we will be calling it as mixing. Okay. With this, let's continue the various type of representations. For an example, an amplifier gain is given, and we are taking a feedback line like this, and it is connected with the feedback factor beta like this. On the input side, also same type of connection has been given. What is the name of this configuration, sir? It is very simple. Don't memorize anything, just observe. On the output side, this is parallel. This configuration is called a parallel. Output side, we are performing sampling. Input side, we are performing mixing. In output side, from parallel circuit, we will be taking voltage as the sampling. On the input side, in parallel circuit, we are mixing the current, and this is called the shunt configuration. So what I can call this topology is called on the output side voltage, input side is shunt. So that is called voltage shunt topology, or see output side voltage means this is also called shunt only, parallel configuration only, na sir. Observe the circuit. This is parallel configuration. So either you can call it as voltage shunt topology or shunt topology, because in place of voltage we can put shunt. So this is also called shunt topology. Like that you can name for whatever the circuit that they are giving. Now, first focus on the circuit, whether the output is series sampling or shunt sampling. Based on that you can give the name. For example, let me take one more circuit. If a circuit will be given like this, how will you name it, sir? This is beta, this is A. Once again we will have to identify the topology. How will you identify the topology? Focus on output and input. If we are focusing on output and input side, on the output side this is series topology, na sir. We will be focusing on series configuration. On the input side we will be focusing on shunt configuration. Now what is the basic primary difference then? If we are observing these two, on the output side we know this is called sampling. On the output side whatever we are performing, that is what we are calling it as sampling. From series sampling we can take current as the output. Current will be sampled here. Shunt configuration means current will be mixed here. So this is called current shunt configuration, current shunt topology, or we can also call it current is nothing but series topology. So it is also called series shunt topology. The alternative name is, it is also called series shunt topology. That's it, sir. So this is how we are identifying the different topologies when it is given in the exam. All you have to do is a proper understanding is very, very important. Now let us moving on to the next one. The another most important factor that you must know here is, I will tell you, the input and the output impedances. Always remember, forget about all these things, input and output. Only remember, see, when we are focusing on, forget about all topologies. If your output is series, then the output resistance will become old resistance, already existing output resistance. Let me call R0 dash. R0 dash equal to old output resistance plus 1 plus A times of beta, where A is the open loop configuration value, AOL. Okay, beta will be feedback factor, both will be given. From this calculate value of output resistor. Suppose if output is shunt configuration, then the value of output resistance is going to be existing value of output resistance divided by 1 plus open loop configuration into beta. That's it. That is the formula. Similarly, focus on the input side. On the input side, if you are having shunt, then the new input resistance after giving this shunt topology will become existing input resistance divided by 1 plus open loop configuration into beta. Now the second thing is, we can also define this new input configuration for series topology, existing value into 1 plus open loop gain into beta. That's it. So these are only two different formulas that we are using to know the value of resistance on the input side, of course at the same time on the output side. That's it, sir. Hope you understand. So it doesn't matter what type of topology that they are giving. What they will ask is, you will be requested to identify the resultant input resistance or resultant output resistance. What you have to do is, what topology will be given on the output side for the given topology, on the output side whether it is series configuration or it is shunt configuration. For series, resistance will increase. If it is shunt on the output side, then the resistance will decrease. Resultant. Similarly, on the input side, for series, resistance will increase. For shunt, resistance will decrease. Just remember the things whatever that I am concluding here, because all these things are very important. Hope you will not forget at any cost. Okay. At the same time, you must remember the other factors that I have given. Apart from all these things, I have also given bandwidth transfer. What I have been told you, whenever they are asking the bandwidth, the existing bandwidth value is BW, that is old. Let me consider. This is new into 1 plus A times of beta. Okay, sir. So this is the another most important formula that you must remember. Now, apart from this, they will also ask a few more questions. What few more questions they will ask? You will be requested to calculate the upper cutoff frequency and the lower cutoff frequency for the given circuit. Sir, how can we figure out the upper cutoff frequency and the lower cutoff frequency? Do you guys have any idea on this? If you are requested to calculate the upper cutoff frequency and the lower cutoff frequency for the same configurations, how will you identify it? What type of formula that you will use to know the upper cutoff frequency and the lower cutoff frequency? If you are requested to calculate the upper cutoff frequency or lower cutoff frequency, always use the relation that I am giving. See, from the bandwidth configuration, what I am saying is, if they are asking resultant upper cutoff frequency or resultant lower cutoff frequency, just recollect once. Once again, you will have to consider this existing factor A times of beta, and they will also give unity gain frequency. So once those two factors will be given, then to know the value of upper cutoff frequency. Upper cutoff frequency is always very high. Lower cutoff frequency, of course, it is very less. For the upper cutoff frequency, existing frequency will get multiplied with 1 plus A times of beta. For lower cutoff frequency with the given unity gain frequency, you will have to divide it by 1 plus beta. Sorry, this will be 1 plus A times of beta. Just remember, sometimes you may be requested to solve these things in the examination. That's it, sir. So this is all about feedback topology. I have given all sufficient things. So the next topic that we are going to discuss now is, let us start, that is operational amplifier. Next topic, sorry, we are going to discuss about op-amp, operational amplifier. Wait 1 second. Okay, let us start. When we are observing the operational amplifier circuits, just to recollect what we did in op-amp. What are the basic properties? Operational amplifier is one of the most important topic. As you are observing, it has been repeatedly asked in so many exams. In any of the exam, you cannot find the question paper without the question from the operational amplifier. So it is very important to know the properties of the operational amplifier. First, let us deal with the ideal operational amplifier, and let us see its symbol. This is the symbolic representation of the op-amp. It is having three terminals. One is positive terminal, negative terminal, and another one is output terminal. So it is having two input terminals and one output terminal. First, it is having two input terminal and one output terminal. And how should I measure the value of output voltage, sir? I am not showing all the internal configurations. For time being, just to note down everything, because it is revision class, it is not possible for me to revise everything. So I am just bringing the relations. So the first thing is the voltage that we are injecting across the non-inverting terminal. Positive terminal is simply called non-inverting terminal. The voltage that we are injecting across the non-inverting terminal is called non-inverting voltage. And if we are inverting, if the voltage will be injected across the inverting terminal, then we are calling it as inverting voltage. So there are two voltages, one is non-inverting voltage and another one is inverting voltage. Now after that, let us define the value of output voltage is going to be gain of the operational amplifier, open loop gain of the operational amplifier into the terminal potential difference between the positive terminal and the negative terminal, that is non-inverting terminal versus inverting terminal. This is the general output measurement of the operational amplifier. Now I will tell you one by one from here. When the moment we are measuring the value of the gain, the operational amplifier can be classified into two types. One is ideal operational amplifier. The another one is practical operational amplifier. That is the most important thing that you must understand. When we are playing with the ideal operational amplifier, the properties of the ideal operational amplifier will be repeatedly asked in the exam. What is the basic properties of the operational amplifier? I will tell you each and every term one by one. You just focus on it. The first thing is input impedance offered by the operational amplifier will be approaching to infinity. Input impedance will be measuring between the inverting and the non-inverting terminal. It will be here internally. So that input impedance value is infinity. in ideal circuit, but practical circuit it is in the order of mega ohm or very high we can say, but it is not infinity in practical circuit. When we are observing the output impedance offered by the op amp, that will be 0. The output impedance offered by the op amp will be 0 ampere. But practically it is very low. It is very low. That is the one of the most important property of the operation amplifier. The next one is gain of the operation amplifier. The open loop gain of the operation amplifier will be approaching the infinity. The gain of the open loop operation amplifier will always be approaching to infinity. Remember, this is one of the most important property. But in the practical circuit, it is in the order of approximately 10 power 7. So gain of the operation amplifier is very high, sir. That is what we would like to conclude here. So in general, the operation amplifier gain is very high. That is the another most important property of the operation amplifier. Next, there are certain current on the input side. We will be considering it as input bias current. The value of the input bias current will be 0. But in practical operation amplifier, this bias current is not equal to 0. And we might have studied that one more term, that is called input offset current. In ideal operation amplifier, input offset current will be 0. But in practical operation amplifier, of course, you can expect some offset current. It is not equal to 0. It is in the order of microampere. So that is bias current. Next, if you are observing input offset voltage, in case of ideal operation amplifier, the input offset voltage will be approaching to 0. Input offset voltage offered by the operation amplifier will be 0, but in the practical circuit it is not 0. The value of the offset voltage is not equal to 0 in practical circuit. It is in the order of millivolt. Okay. Next, the another most important property is common mode rejection ratio, CMRR. The value of the CMRR in case of ideal operation amplifier is very high. Whereas in the practical operation amplifier, in ideal operation amplifier it is infinity. In practical operation amplifier it is very high. You should not forget, sir, common mode rejection ratio is one of the most important term here. Okay. So that you must register in your mind. So these things are a little bit important term, and of course these are all called properties of the operation amplifier. Now, when we are playing with the operation amplifier, the first most important application of the open loop configuration is the first one application is it will be used as a comparator circuit. How it is working as a comparator? I will tell you. On the input side, based on the amount of voltage that we are injecting across the inverting and the non-inverting terminal, what will happen is when we are entering into the application of operation amplifier, the first most important application is it can act as a comparator circuit. So when it will act as a comparator circuit, I will tell you. Basically, operational amplifier is having two regions. If you are observing the transfer characteristics of the operational amplifier, I will show you. What it will do is the operation amplifier, it will give linear relations up to a certain point between input and output. After that, it will get saturated. Now it is having two regions here. If you are observing the characteristics, as we have seen, the output relation, output can be written as open loop gain into the relation between difference between inverting and non-inverting terminal. This relation is a valid relation, and by using this formula you can find out the output voltage gain if and only if your operational amplifier is operated in the linear region. So this is the linear region. With respect to input, we will be drawing the output. This overall voltage, we will be treating it as input voltage here. So the output voltage and input voltage are directly proportional to each other in linear region. But your operational amplifier will get saturated after a certain time period. It is also having some saturation point. Once we are reaching that saturation point, then operational amplifier will get saturated. So this is maximum plus reset. We are calling it as maximum positive saturation voltage. Similarly, you can perform the same thing on the negative side also. You can perform the same thing on the negative side also. And here also, negative side also it will get saturated. So on the negative side also it is having linear relation up to a certain point. It is linear. This zone is linear zone. Sir, it will be in the positive zone here. If the value of V plus is greater than V minus, then the resultant output voltage is positive. Then you will be lying in the first quadrant. Suppose if the value of V minus is greater than V plus, then you will be getting negative voltage. You will be in linear zone only, but you will be in the negative zone, third quadrant. But even in the negative zone also, there will be a saturation point. It will not go beyond that point. So that is the maximum negative saturation voltage. That is on the negative side. So operational amplifier is having certain bandwidth here. What bandwidth that is, I will show you. So the bandwidth is, it is lies between plus Vsat to minus Vsat. That is the bandwidth of the operational amplifier. So it is lying between plus Vsat to minus Vsat. We can represent like this, sir. So in some cases it will operate in the linear region. In some applications we are operating the operational amplifier in linear region. In some applications we will be operating the operational amplifier in saturation region. So the operational amplifier voltage will be floating between plus or minus V0. Okay. So when it will be reaching these conditions, I will tell you. The thing is, there is a certain saturation point for your operational amplifier. For an example, it is given that plus or minus Vsat magnitude has been given as 15 voltage. It is given that 15 voltage. Now, what we are doing is, when the moment you are calculating the output value of the operational amplifier by using the formula, let us take V plus is given something and V minus value is given something, open loop gain value is given something. I don't want to mention any specific values. I'm just saying, let us assume there are certain values for this. Because of these certain values, what happens is the output voltage value will become greater than the value of Vsat. If it values goes to greater than plus Vsat, or if the value of V0 is go to less than minus Vsat, then in that case, this output voltage will not be possible. So what you have to do? When the moment I am calculating the output voltage, if the value of the output voltage is if it is less than plus 15 and if it is greater than minus 15, then the relation between input and output is linear. For whatever the value that they are giving on the input side, for the respective voltage you can calculate the output voltage. If the output voltage ranges lies between minus 15 to plus 15 while giving different voltages on the input side, then that voltage is acceptable. For different value of the input voltage, if the value of the output voltage crosses this margin, then irrespective of the input voltage, output voltage either follows plus Vsat or it is follows minus Vsat. So operational amplifier entering into saturation region when the value of, that is what we are observing in the transfer characteristics. The maximum allowed voltage we have seen in the transfer characteristics. Plus or minus Vsat is the maximum allowable voltage. If your output voltage is going beyond the saturation voltage, that is invalid value. Na? So that value will be replaced by maximum saturation point. So you will be saying that no, this is the maximum value. So for example, I said we are taking plus or minus 15 saturation voltage, na sir. While calculating output voltage by using the input relation, you found that not only this, by using any kind of other feedback combinations also, you found that the value of output voltage is coming out to be 20 and plus or minus 15 voltage is different in the question. If it is different, the maximum plus or minus saturation voltage is 15. You cannot consider this value. On the positive side, the maximum accepted voltage only plus 15. So the correct answer will be plus 15. This is not your correct answer. So while solving the questions on the examination, you have to be very careful that if the saturation voltage is given, remember one thing. Suppose if the saturation voltage is not given, sir, then how can I find out whether the output voltage is maximum, whether it is crossing the saturation voltage or not? If it is not given, whatever the value that you are getting on the output side, by default that will be your answer. If saturation voltage is mentioned, then you will have to identify whether the resultant output voltage is greater than saturation voltage or less than saturation voltage. If it is less than saturation voltage, then there is no problem. If it is greater than saturation voltage, then saturation voltage itself will be the answer. Hope you understand, sir. This is the important characteristics of the operational amplifier. Now I will show you, as I told you, I am going to operate this operation amplifier in saturation region to design the comparator circuit. Because you can observe that comparator circuit is playing a vital role in analog electronics. Sorry, in digital circuits. In analog to digital converter, digital to analog converter, you can observe this. Let us see, when we are talking about a comparator circuit, for that we are simply operating the op amp at the saturation region. Let us say this is plus Vsat. I am not taking any specific value. This is minus Vsat. Now let us take, there are two terminal voltages, V plus, V minus. What will happen is, on the input side, case number 1, if the value of V plus is greater than V minus, then the output voltage V0 will become open loop gain A0 L into V plus minus V minus. What will happen here? If the value of V plus is greater than V minus, then the output voltage will be plus Vsat. Now, since the input quantities are variable quantities, you can apply sinusoidal voltage or you can do something else. Suppose during this variation, if the value of output voltage V minus will become greater than the value of V plus, then output voltage will be shifted to minus Vsat. So the output voltage is constantly floating between, plus Vsat and minus Vsat, plus Vsat and minus Vsat. That is the comparator output. That is how we are generating a square waveform with the help of operation amplifier. So it is just floating. It will be maintained as plus Vsat till the value of V plus is greater than V minus. Then it will be shifting to minus Vsat when the V minus value will become greater than plus V plus. So constantly it will be floating between plus or minus Vsat based on the comparison of the available voltage across the inverting and the non-inverting terminals. Understand, sir? This is one of the most important thing. Next, you must know about inverting and non-inverting operation amplifiers. For that, we will be applying the next concept, that is called the concept of virtual grounding. Concept of virtual grounding. Since the input resistance offered by the operational amplifier is very high, because of that there will be no any current flow. I will show you. We saw there are two terminals for the operation amplifier. I am not showing the internal configuration. Right. Now this is the V plus value, this is V minus value. Just revise everything in the examination point of view. No need to study everything in detail. So here, from the concept of, whenever virtual grounding concept means positive terminal, non-inverting terminal voltage and inverting terminal voltage both are equal. That is the concept, that is called the concept of virtual grounding. You can apply this concept of virtual grounding whenever negative feedback will be given in the operational amplifier. Observe whether the negative feedback is given or not. Means, from the negative terminal, this is the inverting terminal, from the negative terminal you can observe that there will be a feedback line that is flowing through the output. Whenever you are observing, at all cases, it will be mentioned. They will say that you cannot apply the concept of virtual grounding, or they will give some key points should not apply. In the examination, whenever negative feedback will be given, 100% you can apply the concept of virtual grounding. Sir, in what case it cannot be applied? If you cannot apply the concept of virtual grounding, then they will mention that it is the practical operation amplifier or the input resistance is limited. It is not possible for us to apply the value of V plus minus equal to V minus. Like that, a certain data will be given. So if nothing is given, only op amp is given with a negative feedback, then you can directly apply, blindly close your eyes and apply the concept of virtual grounding. Sir, I am revising this only for TRB and Barc exam. After the exam, for GATE, we will go with the in-depth explanation. Some other things are required. I will define that, how to calculate the practical operation amplifier calculations at all. But here that is not required. As you people are preparing for state exams, they are very easy exams. And Barc also, 2 more questions will not be much lengthy, 3 more questions. Because time is limited, you can easily solve within the given time. Let's continue, sir. So virtual grounding concept will be applied whenever negative feedback operation amplifier will be given. Okay, based on this, let me design. Let us recollect the concept of inverting and non-inverting terminal operation amplifiers. Just recollect. What we have performed is, sir, suppose if an operational amplifier will be given with the negative feedback. So feedback resistance will be given here, and the supply voltage will be given across the inverting terminal. So what will be your output, sir? We know the gain of the operation amplifier in this case. This is called inverting operation amplifier, and the value of output voltage will become minus RF by R into input voltage. Yes or no, sir? Just to recollect once because it is revision class. Similarly, same thing if the supply voltage will be given across the non-inverting terminal, then the output voltage will become 1 plus RF by R into Vn. What is the conclusion here? If the supply voltage will be given across the inverting terminal, then the output voltage will be 180 degrees shifted from input. That's why we are getting this negative sign. If the supply voltage will be given across the non-inverting terminal, then there will be no inversion between input and output. You can observe the phase shifting between the input and output will be 0 degree. This is for non-inverting operational amplifier. This is for inverting operational amplifier. Right, no, sir? So these things you must remember. So that is the basic difference between inverting operational amplifier and a non-inverting operational amplifier. Now, based on the concept of virtual grounding, we will be designing so many different applications. We can design voltage follower circuit, and we can design summer circuit, different circuit, anti-logarithmic circuit. So those things you can just recollect once. But my suggestion is don't do anything, don't memorize anything. Always remember one thing. Suppose if an operational amplifier will be given to you with a negative feedback, apply a simple rule. What simple rule? Negative terminal, non-negative terminal. See, okay, input voltage will be given here simply. I'm just showing you how to perform. Don't memorize any of the application, not required. This is the resistor R. This is feedback resistor. This is the input voltage. First step, it is negative feedback circuit, na sir? Negative feedback circuit. Yes. So we can apply the concept of virtual grounding. V plus equal to V minus. Now if you observe, V plus is directly connected with the ground. What is the value? 0. So same 0 voltage will be reflecting here. The next step is apply the concept of ideal op amp. The current entering into the op amp will be 0 ampere here. Fixed, you can just follow this. Now apply nodal at this node. Let me consider that node is X and the corresponding voltage is Vx. We know the value of Vx will be 0 voltage. Now according to the nodal, selected node is the superior one, and that will going to deliver the current for the entire circuit. Let me consider I1, I2. Just to learn how to apply nodal over there. Now let me write down the expression for only two branches are there. The branch that is connected with the op amp is consuming 0 ampere. So I am ignoring it. Now write down the expression for current I1 0 minus V0 by feedback resistance RF. Nodal analysis. 0 minus input voltage Vn by input resistance Rn equal to 0. Now solve this question. Solve this, sir. What you'll be getting? V0 equal to minus RF by input resistance Rn into Vn. So what you have to understand here is the relation between input and output. That is how we are bringing the relation. It doesn't matter what type of circuit that they are giving. All you have to do is apply the concept of virtual grounding with a negative feedback. Cross check whether negative feedback is there or not. Then directly apply the concept of virtual grounding, and always remember in ideal operation amplifier here the current consumption, the current consumed by the op amp is always equal to 0 ampere. Remember only these basic things and apply, you will be getting the answer. I'll show you one more example also if you want. Wait. Let us assume I am having an operational amplifier circuit like this. It is directly connected with the ground. And here we are having negative terminal, positive terminal. Okay, sorry. This is negative terminal, this is positive terminal. So what I am doing is negative, positive, and here let us connect it with the supply voltage. This is input voltage. Let us take some input resistor. Let me take resistor R. Let me take, this is feedback resistor. Sir, how to calculate the value of output voltage V0? Simple step. As I told you, just apply. See, the one and only thing is step number 1. Negative feedback is there. apply the concept of virtual grounding. And remember, the current entering into the operation amplifier is always 0 ampere. So from here, 0 ampere current only will go, because op amp will not consume any current. So if it is 0 ampere, then what is the voltage drop here? That is 0 voltage, 0 ampere into internal voltage resistor. That is 0 voltage. So we are offering plus Vn, sir. Nothing will be dropped across the input resistor. So this total voltage will be reflected across the inverting non-inverting terminal V plus. So the value of V plus will be simply equal to Vn. That is equal to V minus also, because from the concept of virtual grounding, inverting terminal voltage and non-inverting terminal voltage both are equal. Now apply nodal at the same point. Now we know at this point we have Vn. According to nodal, there are two branches. Yes, let me consider the current I1 and I2 here. Now what will be getting, sir? From this I can write from nodal Vn minus V0 by Rf plus Vn minus 0 by R equal to 0. Now solve this expression, you will be getting V0 equal to 1 plus feedback resistance Rf by R into input value Vn. That's it, sir. This is how we are solving any type of general operation amplifier within the concept of virtual grounding. You don't need to name it, sir. You don't need to name it. Just apply the concept of virtual grounding. That will give you the answer for all type of circuits. Understand? So apart from this, in operation amplifier, we will have to know, we must learn how to calculate the input resistance when it is asked in the examination, and how to calculate the bias current, and if bias current and by offset voltage are given, how to calculate the value of output voltage V0. These are only some of the these are the properties of practical operation amplifier. So these things we will cover in the next class. With this, let's wind up the today's session. If you have any doubts, you can always drop your doubt in the comment section. Your answer will be, sorry, your doubts will be resolved shortly. This is all for this lecture. Remaining